So we will use this distillation technique only for separating what? Distillation technique, TECHNIQU, distillation technique only for what? Homogeneous mixtures. Homogeneous mixtures. Now, that homogeneous mixtures also, all of you should remember. I will take a solution. Suppose if I'll take a solution of some kind of a substance, for example, if we'll take, understand, always this is what the some solution, all of you should remember. In this, a solid must be, solid what we should call, Ra? Solid what we should call? Solute. Solute. And the liquid what we should call? Liquid what we should call? Solvent. Understand? So we will use the distillation technique, general distillation. This is called as simple distillation. What I'm saying? Distillation. Also I can call it as simple distillation. What we should call? Simple distillation. Should remember, distillation also we can call it as what? Simple distillation. So we will use this simple distillation. Understanding? We have one more distillation. What is the distillation? Anybody? We have one more distillation. Fractional distillation. The difference between them. That is what I am saying. All of you should remember. So a distillation technique we can use to separate this distillation. Also we can call it as simple distillation. Only we can use, all of you should remember, a solid substance, a solute should be non-volatile. What is that? Non-volatile. Solvent must be volatile in nature. What is that? A solvent must be volatile in nature. Then use for simple distillation. Is it okay, guys?
Okay, sir.
Understand? Suppose, sir, why can't? Now maybe Sai maybe ask me question, sir. If both are both are volatile substances, both solute and solvent, both are volatile, then what will happen, sir? Both are volatile. What do you mean by volatile, guys? Which can easily convert into gas. Easily convert into gaseous state. So that if the solvent is evaporating, solute also will evaporate. Is it yes or no?
Yes, sir.
Yes, sir.
Solute, if solvent is condensing, if the solute also will condensing, so that again we will get back the same mixture. We are not going to get separate components. Is it yes or no? So that is why a simple distillation or distillation, we cannot not use the distillation technique if both are what? If both are volatile substances. Understand, Ra? Both are volatile substances. So one must be volatile, another one must be non-volatile. So basically, which one must be volatile? Solvent must be volatile. Solvent must be what? Volatile. Easily can convert into gas, and again we are condensing back into liquid. Understand? So solvent must be volatile in nature so that we can heat. If we will heat it, it will be converting into what? Gaseous state. That is what we call as vapor. And again we can cooling. It will be coming back what? Liquid will come back. Understand? But solute, if we'll take the solute is a water other one. Non-volatile substance. What is that? Non-volatile substance. It is remains in that beaker only. Understand, Laksha? Remains. Understand? In same container. Remains in container. Do you understand, all of you? Respond me, please.
Yes, sir.
That is what you have to use. So simple distillation or distillation only we can use for what purposes, Ra? A solid. A solute must be a non-volatile and solvent must be a what? Volatile substance. Only we can use this one. So why it is, you may be understand. If you use for both volatile substances, again both will evaporate, again both will condense. So it is not possible to separate it. Understand, guys? Yes. So once you are doing fractional distillation, you maybe understand this more even clearly. So all of you should remember always the boiling point difference between the boiling points of solute and solvent. Solute and solvent is more than 25 degrees Celsius. More than 25 degrees Celsius. Then only we will use the simple distillation or distillation. Is it okay, guys? Boiling point. Understand? The boiling point of solute and solvent is more than how much, Ra? More than 25 degrees Celsius. Then only we can use the
45 degrees Celsius.
simple distillation. If it is less than that, if it is less than, we will go for fractional distillation. What is
Fractional distillation.
fractional distillation? That we will
Fractional
study later.
distillation.
Now that is not a matter. Now we are going to separate one of the given solution called as, already I have taught you that. What is that example? Given solution. What is that example? So to separate the salt water mixture. What is that? To separate the salt water mixture. How we have to do it too? To separate salt water mixture, or else we can call it as what? Another name. What is another name?
Salt solution.
Salt solution.
Salt solution. Now you tell me, in salt solution, who is volatile and who is non-volatile? Salt solution.
Sir,
Sir, water is volatile.
Water is volatile,
Salt is
sir.
a
And salt is non-volatile.
volatile substance. Next, water is a what? Water is a volatile substance. Purinjicha, guys. So that is why. So we can use both are volatile, non-volatile. So shall we use the simple distillation? We can use the simple distillation technique. Is it understand, guys? Yes or no? Nobody will ask.
Yes, sir.
Simple distillation technique. So let us
Fractional distillation.
simple distillation. Understand? So I will show you what is the experimental setup. All of you understand very carefully. So we are condensing here. So to condense the liquid vapor, we are using something called as what? Condenser. What we are using? Condenser.
Condenser.
Which will condense the vapor is called as condenser. What we should call? Condenser. Understand, Ra? So we are taking a experimental setup. This is what the experimental setup of the simple distillation. Can you able to see the screen? Yes? No. Now observe very carefully. This is what the experimental setup of what, Ra? Simple distillation. What is that?
Simple distillation.
Simple distillation. Understand? So this is what the experimental setup of simple distillation. So now observe very carefully, guys. Yeah. So now here what will happen? First, I have to take a mixture of, what is that, Ra? What is that? Mixture of salt and water. That is what we should call as salt solution. In which one? Distillation flask. What we should call this one? Distillation flask. This beaker is called as distillation flask. So we have to arrange on where? On the wire gauge. On the wire gauge, and I have to be set up a burner tripod stand. This stand is called as what? Tripod stand. Tripod stand. And we have to arrange this fire. Understand, guys? Fire setup we have to be arrange this. Now this flask is called as what? What is this flask called as? What is this flask called as? Distillation flask.
Distillation flask.
Flask. So up we are keeping a rubber understanding rubber what we should call it is called as
Cork.
rubber cork, and middle we are arranging something. What is this called?
Thermometer.
Thermometer. What is the use of thermometer, Elmokil? To identify
To find the temperature.
the boiling point of water. Understand? We are taking salt and water mixture, so that water only. Now, whatever the water evaporated, it will forms in the water vapor. Is it yes or no? Yes or no? So these water vapor are transported through water. Through the condenser. Where it is transported? Condenser. Understand, guys? Condenser.
Yes, sir.
So now this condenser is like a pipe, outside pipe, which is contains inside a smaller pipe. Is it okay, guys? Inside it contains smaller
Yes, sir.
pipe. This is what the condenser. Now it is a ring-like structure. Understand? So this is the pipe which is connected to the distillation flask. Have you noticed it, guys? This is the pipe which has been connected
Yes,
to
sir.
distillation flask. So through that, what is flowing? Water vapors are flowing. What is flowing? Water vapors are flowing.
Water vapors are flowing.
We want to cool it. Sir, how to cool it? How we are cooling? We are decreasing the temperature. By decreasing temperature, it is cooling. Is it yes or no? Is it yes or
Yes,
no?
sir.
Decreasing temperature. Sir, how to decrease the temperature here means, you can see, we are sending the outer ring, not inside the ring. Inside ring, who is passing? Water vapor is passing inside. Understand, guys? inside this tube, water vapor is passing. So now outside we have a two walls, outside ring we have a two walls. So we are connecting inlet flow and outlet flow. What is this? Outlet flow. This is called as outlet flow and this is called as inlet flow.
Inlet flow.
Now, in this what we will do means, we will pass the normal water or cold water. What will happen, guys? Normal water or cold water. Understand?
Cold water.
Normal water or cold will pass so that this water will come and contact with this inner tube. Is it yes or no? Come and contact with this inner tube. Is it yes or no?
Yes, sir.
Now suppose if you touch suppose your mother is filled the hot water in the container. Now if you touch the outside surface, what will happen? The heat will absorb or not? Heat will absorb or not, guys? If people are touch the outside the bowl, it will hot or not? Respond me, Darun, Tamil Selvan. Inside
Yes,
hot water, if you touch the outside the container, you will feel hot or not? That is what my question.
Yes, sir.
Yes, sir.
When I am sending the understanding the cool water to this outer pipe, so that it will go and will contact with this understanding inner tube, so that heat will exchange. Heat will exchange. Understand? So, from the water vapor, the heat is absorbed by this water, and this water is continuously flowing. Here it will enter, here it will leave, so that the water vapor temperature falls down. So the temperature falls down, what will happen? It will condenses. It will condenses into the liquid, and that is what we are collecting into the what? We are collecting into the beaker. So this is what we should call as pure water. What we should call? Pure water. It is done by distillation. So that is why this is called as distilled water. What we should call?
Distilled water.
Distilled water.
Here we are using water. So that is why it is distilled water. If we any other substance, what we should call? Distillate. What we should call? Distillate. Distillate. So here we know water. That is why it is called as distilled water. So is it good to consume this water? Is it good to consume this water?
No.
Very danger. Understand? So those who are drinking the distilled water, it may be leads to the death also, because it not contains any kind of minerals. Understand, guys? But we can add this minerals. So we are having a lot of importance of this distilled water in our chemistry laboratory. Ours, when I'm in university, we used to prepare the distilled water for the experiment. Some experiments can carried out only with the distilled water. We used to prepare by using this distillation setup. Ourselves, we used to prepare the distilled water. Now, the real experiment I will show you. You can see the inner tube. Remember here, people like Maunish, they may ask you, sir, here inner tube and outer tube are connected both? No. Inner tube is connected to the distillation flask. Understand, guys? Outer tube is just like what? Just like outer ring, where outside water will go and will come out. That is what. Understand, guys? This is called as distillation technique. For what? For separating one volatile, another one is what?
Non-volatile.
Substance. Volatile and
Non-volatile.
Non-volatile substance.
Non-volatile
So
substance.
now, simple distillation I will show you. Observe very carefully. So how the simple distillation will be present. So inner tube and outer tube. Two tubes are present. How many tubes are? Inner tube and outer tube. Understand?
Two tubes, sir.
So there is no connection between the inner tube and outer tube. Outer tube is separate, inner tube is separate. You can observe. For example, you can see in these pictures, you can able to see more clearly. All of you see this picture? Can you able to see here, guys? Here you can see. So you see here, inner tube is directly connected. No kind of connection between the inner tube and outer tube. Is it yes or no? Inner tube, which gas will pass? Here you can check it. Inner tube is just coming directly. Is it yes or no? So inner tube only will passes the water vapor or else any kind of vapor. So outside tube what? Cold water will go like this and it will leave like this. Is it okay, guys? Yes or no? Nobody will.
Yes, sir.
Is what you have to remember. So this is what distillation setup. If you'll see here, this is the real experimental setup. This is the real experimental setup of simple distillation. Distillation also we can call it as what? Simple distillation. Understand, Ra? Simple distillation.
Simple distillation.
Watch this video. You may understand more clearly. So observe all of you very carefully. Simple distillation.
of components of a mixture containing two miscible liquids that boil without decomposition and have sufficient difference in their boiling points. The distillation process
Should be there. What is the difference, Ra?
The distillation process involves heating a liquid to its boiling points and transferring the vapors in.
What is the difference, Ra? Boiling point difference should be what? Greater than 25. How much?
Greater than 25 degrees Celsius.
25. Less than 25, we cannot use it because again both will evaporate, both will condensate. That is why we cannot use it. So the minimum point difference is how much? More than 25.
More
Understand?
than 25.
That is
Yes,
why you
sir.
have to remember. Now you can see. Are you able to see the inner tube, guys? Are you able to see the inner tube? Here you can see. This is what
Yes,
the
sir.
only which will carry what? Water vapors.
Only water vapor.
Vapor solution. Understand? Vapor. Now outside you can see here. Outside tube we are connecting the cold water. So this cold water will go like this and it will leave like this. Do you understand, Ra? That's all. So only outer surface it will be there. Okay. So outer surface this water will flow. Now you can see that setup how it will be taking place. Oh, sorry. We stop sharing screen. Okay. Now you can check it. Observe very carefully. So this is the experimental. So here it is condensing back. So that is what we should call, Ra? Distillate. What we should call?
Distillate.
So what is that?
Distillate.
Materials required, you can see. Porcelain chips, they are saying mixture of acetone and water. This is actually separation of acetone and water. Acetone and water. So both are liquid only. Is it okay, guys? Solution only, that is also.
Okay, sir.
Separate
Yes, sir.
acetone as well as water. That is. Now you can see. This is what arrangement procedure. We have to arrange the experimental setup like this. See, this is the experimental setup, exactly like in the picture. Is it yes or no? Now you can see, if they will start heating,
Sir.
you can notice it. So here we are taking water, inlet and outlet flow. So we are taking not here salt solution. What we are taking here? Acetone and water. Understand? Acetone and water. Okay, guys?
Acetone and water.
And water. So they are both are liquids only. You can see here. When the inlet flow started, water level is increasing. Is it yes or no? Only outside it is, not
Yes,
inside.
sir.
So outside it is increasing, so they will be coming back here again. You can check it. For cooling only, just taking the heat energy. That's all. Nothing is there. See what level rises. They will start coming outside. Here they will come outside. Have you noticed it? Yes or no? Now you can
Yes,
see.
sir.
I am heating the acetone and water. So I am observing the fumes. So what fumes now will rises? What fumes will rises? Acetone or water? Acetone fumes will rises. What is that?
Acetone, sir.
Acetone fumes.
Acetone.
Acetone boiling point is less than water. Acetone boiling point is less than water. Understand? That is why. You can check it here. So the fumes are forming. Have you noticed it? Condensing happening. Condensation is
Sir.
that is
Sir.
what. So the liquid is condensing. That is what we should call it as acetone. So what is the temperature? You can check it. What is the temperature you observed? What is the temperature you observed, Ra?
100 degrees Celsius, sir.
Is what? Boiling point of what? 100 is the boiling point of what?
Acetone.
What? Water. What is that? 100 is the boiling point of water. Understand? That is. So remaining liquid. What is here remaining liquid? One liquid is evaporated and it is condensing back.
Distillate, sir. Distillate.
Okay. One more liquid will be present. That is what you have to remember here.
Be separated only and water boils at 100 degrees Celsius. Therefore, the miscible mixture of acetone and distilled water can be separated only by simple distillation. Since the acetone and water mixture forms an azeotrope, the procedure needs to be repeated to obtain the components in the pure state. behind in the distillation process, acetone vaporizes and the vapors pass through the condenser and condensation occurs. The acetone is collected in the receiver flask in the liquid form and water is left behind in the distillation flask.
Understand, Ra?
Acetone.
So, distillation flask will be there, water will be at distillation, because what is the water boiling point? What is the water boiling point, Rasai? Water boiling point
Sir, 100 degrees Celsius.
Celsius, but
100
the acetone. So acetone, if you take, so acetone boiling point is, what is that? Acetone boiling point is less than 100, and the difference is around, understand, it is around 78 degrees, 56 to 57 degrees Celsius itself. So it is having a lot of difference. Is it yes or no, guys? Yes or no? So that
Sir.
is boiling point of acetone is 56. So 56 to 57. But water boiling point is how much, Ra? 100. So
100 degrees
what is the
Celsius.
boiling point difference? Boiling point difference is more than 25 degrees. Is it yes or no? More than 25.
Sir,
So that is why we can use which technique, Ra? Simple distillation.
simple distillation.
Simple distillation. So that is what we are used to get as a distillate. What we'll get? Water or acetone? Water or acetone will get. Acetone as a distillate.
Acetone, sir.
Water will be remains in the distillation flask. So that is what it is called as simple distillation. So we are using when we will use this simple distillation, once the temperature difference is more than the boiling point difference is more than 25 degrees Celsius, then only we can use what? We can use what? Ra? Simple distillation. Understand? If it is less than,
Yes, sir.
we can use what? If it is less than that, we can use what? We can use the fractional distillation. That is what we will study in the next class. So with this, I will stop today's class. Thank you, all of you.
Thank you, sir.
Thank you, everybody.
Thank you, sir.
Bye.